IPMAT 2021 short answer question. What is the minimum number of weights which enable us to weigh any integer number of grams of gold from 1 to 100 on a standard balance with two pans, and weights can be placed only on the left pan? Wow. For students who know how binary system of numbers work or any alternate other than the decimal number systems work, this is a sitter question. You look at the numbers, you get the answer, no calculation required. But for students who don't know it, let me just explain to you the funda. So what is meant by the binary system? Binary system is system of numbers which contain only the numbers, the digits 0 and 1 in them, right? When we talk about the standard decimal system, we have got 10 distinct digits: 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So in binary and in decimal, 0 is 0, 1 is 1. But 2, after 1, the next digit, the next number which I get represented by only ones and zeros is 1 0, then 1 1, then 1 0 0, then 1 0 1, and so on and so forth. Right? This is a very intuitive way of finding out the numbers. The actual practical way is you have numbers. So 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 4. If I'm using the number, I will represent it by a 1. If I don't need it, I will represent it by a 0. So the values of this are 1, 2, 4, 8 and so on. For 0, I don't need anything. So I can simply represent a 0 with 0. For a 1, I need a 1. Right? So these are addition of numbers. For 3, 2 plus 1. For 2, I just need a 2. And I don't need a 1. So 1, 0. For 3, 2 plus 1. So 1 and 1. For 4, I need a 4. I don't need the 2's and 1's. So 1, 0, 0. Right? So using this system, I can come up with my numbers. What has that to do with this problem? Absolutely easy. If I need a minimum number of weights to measure from 1 to 100, then let's see how this works. If I've got a standard weight of 1, I can measure 1. If I've got 1 and 2, I can measure 1, 2 and 3. If I've got a 1, 2 and 4, then I can measure 1, 2, 3, 4. For 5, 4 plus 1. For 6, 4 and 2. For 7, 4, 2 and 1. Then if I have a 1, 2, 4 and 8, then I can measure 1, 2, 3, 4, 5, 6, 7, 8. Then 8 plus 1, 9, 8 plus 2, 10, 8 plus 2 plus 1, 11, 8 plus 4, 12, 8 plus 4 plus 1 is 13, 8 plus 4 plus 2 is 14, and 8 plus 4 plus 2 plus 1, 15. Right? So I'm increasing weights in the powers of 2, and I can measure up to the next powers less. So if I have got 1, 2, 4, 8 and 16, then I can measure till 2 raised to 0, 2 raised to 1 plus 1, so this is 2 cube minus 1, 2 raised to 4 minus 1, 2 raised to 5 minus 1. So 2 raised to 6 minus 1 till 31. If I add the weight of 32, then I can measure till 63. So 1, 2, 4, 8, 16 and 32 till 63. And 1, 2, 4, 8, 16, 32 and 64. I can measure till 127, but I need to measure only till 100. So using just these weights, 1, 2, 4, 8, 16, 32, 64, that is 1, 2, 3, 4, 5, 6, using these 7 weights, I can definitely measure up to 100. In fact, up to 127 I can measure, right? So I just need 7 of these distinct weights, that is powers of 2, right? So this is a very interesting problem which has come in many riddles. It explains to you how numbers are formed in the binary system.